Okay, hey guys, welcome back to my YouTube channel. So I just record my solution and I explain how it works, but I haven't read the problem statement. So let's read it together. So Lang and Tao go by some stationery, and there are n types of pens from 1 to n, and each pen, or like each type, has the price AI, and they decide to buy the different types, different types. Okay, so there are some rules. So if that price is less than K, then a line will pay the whole price, and if the and like otherwise a line will pay K only, and then the rest Tau will pay, and then line wants to um choose M types such that line price minus T price, Tau price, as small as possible. So we have Q queries over here, and our mission is um, to print L minus T over here. So first of all, what you're gonna do is you're gonna sort your arrays over here so you can get a good look. So for example, we have these types. So I'm going to sort it out for you. So 18, 20, 25 over here, 20. Okay, so for the first test case over here, so you notice that Lang will pay just like maximum is 15, and then we need three types. Okay, so um first of all, what you're gonna think is that you want this will be as small as possible. So why not be so greedy and you choose M types that has cots, the minimum cots. Okay, so like the idea is choose M types that cots the smallest. Okay, so that's what we're going to try to reach. So first of all, we're going to use lane and tail, lane and tail. Okay, so you know that tail will pay here, like here, and we'll pay 000, and here 3, 5, and 10. Now you can see, I'm just saying my observation over here. If this is really big, so that will pay a lot, and then line minus tail is super low. Okay, so now we're going to line minus tail. So 0, oh no, 1, 6, 7, 8, and then 12, and then 10, and then 5. So three types over here. So now we have our line minus tail over here, right? So they ask us choose M types such that L minus T is the least. So we just make our arrays really good over here, L minus T. Now what we just need to do is choose M types that cost the smallest. So you just choose M smallest number. So the first one is so the test case they choose 3. So I can see that okay, 1 is the smallest, and 5 is the smallest, and 6 is the smallest. So some of them is 12, obviously. So okay, if you so that yeah. So how can we cool? I mean, this problem, I can really make it easy for you to understand. Okay, so count is numbers that is of number of cost. Cost here is L minus C, mind you. Number of costs that is less than X. So I mean X here is the mid, if that is in your language. So now you have the sum of all count cost. Now you lack. Now you lack now you lack n minus count numbers. Because why you lack? Because you want to choose n numbers, but you only have count numbers, so you lack. So now you add up, you make up. Now your sum, you add minus m minus count times x right here, because the next number is x, obviously. So here is the gist of what I've been saying. And obviously, as I say, the more you get to the right solution, the more it will be right. Because maybe you don't have enough of x, right? Like maybe you don't have enough x, so you just add, increase your L. And if you have too much count over here, then decrease your R. Okay? I like this problem a lot because this is a new type of binary search that I've learned. So this is mind blowing for me, and I want to record. Yeah.
Hi guys, I think this video may be a background for my singing video. Uh, Hope you will like or not. I don't hope. Okay, bye. Hope you enjoy my channel. Yay! I love singing.
How can we calculate L minus T? So it's really easy. You have two Ks. So if your I said that this is the price of the type of the pen type. So if X is 3K, or it's okay, I don't care. So you will pay X, and if you here, then you will pay. So first line you will pay K, and then tail you will pay X minus K, and then line minus tail will be 2K minus X. Okay, so this is your C, and this will always be correct. Okay, so this is a binary search. Why? Because we need to choose M types. Okay, so I'm going to explain. So first of all, let's say so the idea is like you try to choose N numbers, then you set a range, you set a number, so that like every number you choose is less than this number. Okay, let me just remove this a little bit. Try to choose a number. Let's say this number equals to X, less, so to choose is less than X. So now you have count numbers less than X already. So if count is like more than M, then like your X is too low, or you're too high, right? If I take A, for example, so there's a lot of number, but if I take 1, so there's only one number. Okay, so your number is too high, then lower it. Lower it. You're too high. So like else, this is satisfying. What you're going to do is like, okay, so now you have count number is less than X now. So now you have to be like, let me search this a little bit. Okay, so the now you number is too high, you don't do anything. But if it's satisfying, you have your numbers of numbers or less or equal to M, then you lack M minus count numbers, and now you just choose all of number that is less than X. Now your next number is X, right? So that will be X. So you include n minus count times X to your sum. So first I say my sum here. Sum is that like this first number where the X is less than or equals to K. So you just need to find this, and then you need to find numbers that more than K. So you do this. Okay, so for example, I will find it. So this is my X equal to AI, for example. So we just do some math over here in X. So our X is in this one, and yeah. So this is mid, this is our, and you need to find number that is less than this. This is your standard, and you need to find number that less than this. Wait, let me think. Okay, no, this number is my AI. So let me just erase a little bit. So you see that AI equals to L minus T, right? So this is my range. So I want to find AI. I don't want to find X because this my X is the range, the standard. So I need to find AI. How many I's, how many AI's, how many numbers that satisfy this? And here, like how many I's satisfy this, right? Okay. I just explain to you here, right? Okay. So you need to sum now sum of L minus C that AI is less than K, plus sum of L minus C that AI is K. Or I prefer to do this because that is my natural. So you include in your sum. So now this is satisfying, so your M's will be sum. And you will update. This is where the problem gets really interesting. So let's say this is my problem, right? I'm trying to move this a little bit out of the way. Oh my gosh. Okay. So let's say that, okay, I choose 8. So this is my number over here. So that is already more than M. It's 4 already, so I just minimize it. Maybe I take this, I just take 1 and 5. It's 2. It's 2, right? So I just take it. Like, my count now equals to 2. Now I need 3 minus 2, and then let's say my X is 6. Like, or we can do this, for example. It can be very not, let's say 1, right? You see no numbers here is 0 or less than that, so it's going to be wrong. But the more you increase your X, the more right the righter you get. So here you will be like your count here is 0, obviously. So now you're gonna like you're gonna include m minus count, which is 3 minus 0, and now you times your x over here 1. Now your count is obviously here. So what you do is you increase your range. The more it gets, like the more close it gets to the right thing. Like you can obviously do here as well 7. Then you have these two, and then you already have count. Your count is obviously 3. And now you just need to 3 minus 3 equals 0 times 7, which is fine. Like the more you get to the solution, like the closer you get to the solution, the more you get. I mean, do you understand? The more it will be right, because m minus count times 1 is obviously wrong, because you only have a 1, one number 1. So this will be wrong. By increase your range, you will make it righter and righter and righter, and then you will be correct. So here, if your x is too high, then just make it smaller by doing, this is a mid, minus 1, and here is L equals to mid plus 1. Thanks for watching. I hope you liked this problem.